Welcome to the results of our dataset exploration. Today, we'll be tackling the problem on if we can predict how well the public will rate an anime and which variables have an effect on the score of an anime. We are Group 9 from FSP6 and I am Jovian. To start off, we can think of the comparisons between the various prediction models we use to be akin to a tournament, or as people in the anime scene would call it, a
Tournament talk! Tournament talk! It's a tournament talk! Tournament talk!
The datasets used in this data exploration were provided by the movie database as well as from AnyList. So what exactly is the movie database? It is a community-built and driven database, collecting data from movies and TV shows alike. The other dataset used is from AnyList, whose name comes directly from Anime List. It is a website dedicated to keeping track of data of various anime and manga. So, how did we get to anime from the movie database? As most people would usually go with a project based on movie data, given that the website is known as the movie database, but as the movie database also had data on TV shows, we decided to go with something much more unique, especially since that we know that there was an external dataset to back up our primary dataset from TMDB. For the actual collection of data, the movie database's free-to-use API has a function to discover and sort movies and TV shows by genre. I sorted by animated and saved all animated TV shows into an Excel spreadsheet and CSV file. AnyList also had a free-to-use API, which I had heard of before in the past, as I frequently use AnyList myself. I looked up their documentation and used a for loop to save every single page of anime that AnyList had data on, as well as other relevant details such as the name, release date, and rating of the anime. Now, I have to clean and merge the datasets together. First off, TMDB has data from all over the world, hence I cut away the shows listed that were not originating from Japan. Anime also goes by many different names depending on the localization, such as Attack on Titan.
Come on, let's have some fun!
Versus
進撃の巨人
Hence, a function was created to normalize the names as much as possible. As for AnyList has a much bigger dataset on anime, and hence I had to use the same function to normalize the names, before merging the two datasets together, with the final set containing shows that are available on TMDB, while also containing other information such as user rating, source material, and show genre from AnyList. Next, Runi will go through some exploratory data analysis, as well as performing univariate regression on the dataset.
Thank you, Jovian, for your presentation. Now, I'll be presenting on our exploratory data analysis. This is our visualization for score data. Our score data is the combined weighted average score between scores from TMDB and AnyList. And these are our visualization for our predictors data. Now, I'll be going through the univariate linear regression for score versus year released. For linear regression, explained variance is 0.0106, mean square error is 398.95, and root mean square error is 19.97. For quadratic regression, explained variance is 0.0130, mean square error is 397.99, and root mean square error is 19.95. For cubic regression, explained variance is 0.0238, mean square error is 393.64, and root mean square error is 19.84. Now I'll be going through the univariate linear regression for score versus total fans. For linear regression, explained variance is 0.0955, mean square error is 370.69, and root mean square error is 20.54. For quadratic regression, explained variance is 0.1424, mean square error is 351.46, and root mean square error is 18.75. For cubic regression, explained variance is 0.1703, mean square error is 340.03, and root mean square error is 18.44. By comparing the three regression models for both cases, cubic regression has the best explained variance and root mean square error for both. This means that cubic regression is the best for both cases. Now, I'll be passing my time to Ziqing, who will be sharing more on multivariate linear regression.
Now we shall perform multivariate linear regression. We perform linear regression using a Gaussian distribution model. This model produces an explained variance of 0.231 and a root mean squared error of 8.384. Next, we shall try linear regression using other distribution models. Firstly, we have 3D regression. Although this model produces a similar root mean squared error, it has a worse explained variance. Next is ridge regression, which improves on both explained variance and mean squared error. Here we have Bayesian ridge regression. This model has a similar explained variance while producing the best root mean squared error. Next, we have automatic relevance determination regression. This model does not improve on accuracy. Lastly, we have lasso regression. This model also does not improve on accuracy. Conclusion: the Bayesian ridge regression is the best multivariate regression model as it has the best explained variance and root mean squared error. Next, we shall determine the importance of the predictors by plotting their coefficients from our regression model. From the first set of variables, we have year released, total fans, is adult, from Japan, English, Japanese, and other Asian languages. Next, we have European languages, light novel, manga, original, others, video game, and visual novel. Based on the most accurate regression model, the most important variables are originality, manga adaptation, Japanese language, light novel adaptation, and Japanese origin. Next, we perform model blending on the previous regression models, which are assigned weights based on their accuracy. Using this approach, we can reduce the root mean squared error to give a better accuracy. Next, we try polynomial linear regression. By testing each polynomial regression model, we find that the polynomial of degree 5 has the best accuracy. This regression model has an improved explained variance and root mean squared error. We can further improve the accuracy by blending the polynomial regression model with the previous regression models. Model blending with polynomial linear regression produces the best accuracy.
In conclusion, we have determined that we are indeed able to achieve our goals of predicting how well the public may rate an anime, as well as determine which predictors most affect the score of an anime. Based on our data, our insights are that the cubic regression has the best goodness of fit for both year release as well as total fans, and that total fans is a better predictor than year release. As for multivariate analysis, the best model is the Bayesian ridge regression, which told us that the most important factor is whether or not an anime is original. We would thus recommend any anime studio to try and write an original story when producing an anime. If that is difficult, adapting a renowned manga or light novel will boost popularity as well. I am Jovian and I have extracted, prepared, curated, and cleaned the data using 2 different APIs, as well as produced this very video. Rooney visualized the data and performed univariate regression on the dataset. Lastly, Zixing tried new multivariate regression models and blended them together to provide us with the answers to our data science problem. Thank you.